explain the best case, the worst case, and the average case, now I am using a one algorithm called as sequential search algorithm here. First, I will explain the sequential search algorithm. Then I am explaining about the different cases of efficiencies. Okay, what is the meaning of sequential search? Sequential search is nothing but search for a given item. Here one item is given called as key item here, that is K here. Okay, in a list of n elements, by checking successive elements of the list until either a match with the search key is found or the list is exhausted. Now, see the example here, how actually the sequential search work. Now imagine I want to search for a key called as 21. I want to search for a key called as 21 within this list. How actually the sequential search actually do? It will search from the beginning here, from here, okay, one by one up to the end. Till end it will goes. First it will take the first element. I'm comparing with the key called as 21. If both are matching here, then it will return the index value of this one, that is 0 here. Okay, now here there is no match, so it go for the second one here. 10, there is no match, again it go for the next one, next one, next one, next one. Okay, here it reaches here, comparing 21 with the 21, both are matching here, so it will return the index value of this one, that is nothing but 6. It will return 6. Okay, because it is return the element K is located at 6. That is the way the sequential search work. Now check the algorithm here. Is a sequential search algorithm which will accept a list of n elements and a key, searching key. What actually it will do? It will starting from the first element. Searching is starting from the first element, that is indicated by the index value called as I. It's a temporary variable for searching from first element. Now you have to run this loop until I is less than n. That means you have to start from 0 up to n, and the key value should not be matched with the element value. Any one condition is true, this while loop will be when the both conditions are true, this while loop will be stopped. Either I crosses n or the key value is found at the k of I. In that case, our algorithm stops. Okay, here what happens? It will search from 0, 1, 2, like that one. When the key is matching with the AI, this while loop stops and the incrementing stops. Okay, now then we go for here. If I is lesser than n, that means we found a key here. We found a key. Then go to return I. If the key is not found here, a of I is not equal to k is always true. That means I is crossing the n value. Here I is crossing the n value. Then we have to return -1. -1 indicates the key does not exist in the list. I less than n indicates their keys exist in particular location called as I. Now consider the same example here one more time. Now if I want to find out 91, a key called as 91. First what happens? It is matching with the first element. There is no match. Second element, no match. Third element. Here the I value is actually starting from 0. I value is actually starting from 0. I value goes on increase here. And this is the n value here. Okay, this is the n value. Now this is n minus 1 here. Okay, if goes on increase here. Okay, now k is compared with 16. I value is here. K is compared with 16. No, I value becomes 76. Here compared with 91. No match. No match. No match. No match. Go to n minus 1. No match. Go to n here. Whenever it reaches n, our algorithm stops here. Okay, and return minus 1 because I is crossing the n value here. Next one is the worst case, best case, and average case for the sequential search algorithm. Now, imagine that we have given the same size of input. For example, I am giving 10 elements or 10 elements of array to the search. When it will take more time, when it will take less time, that is execute faster, that can be identified by worst case as well as best case. Okay, what is the worst case of sequential search? When the matching element is not found in the array, or the element is present but at the last element of the array. In that case, our searching algorithms take more time. It will consume more processing power at that time. So such situation is called as worst case of the sequential search. See here, when there are no matching elements, or the first matching element happens to be the last one on the list, the algorithm makes the largest number of key comparisons among all possible input of size n. That means the number of key comparison is more when the element is at the last, or the key value is not found in the array. It can be represented as C worst n is equal to n. That means it will take n number of time, linear. Okay, and the best case is when the element is found at the first element. If you are searching a key and the searching key is available in the first element of the array, that is the best case. It will execute only one time. So the C best n is equal to 1. It's a constant. Okay. Now the last one is called as average case efficiency of the sequential search. The standard assumptions are that the probability of successful search is equal to P, where P is in between 0 and 1. In case of successful search, the probability of the first match occurring in the ith position of the list is called as P by n for every I. That means if we found the element at ith position, its probability is P by n. Okay, for every I. That is nothing but I into P by n. The number of comparisons made by the algorithm in such a situation is obviously I. The total number of comparison is done, that is I. In case of unsuccessful search, the number of comparisons will be n. with the probability of such search being 1 minus p. So whenever the unsuccessful search occurs, that is nothing but n into 1 minus p. Whenever a successful search occurs at the ith position, it is nothing but I into n divided by p. If element is at the first position, the probability is 1 into p by n. Whenever for that one we have a formula, C average of n is equal to, if probability of first element is 1 into p by n, probability of second element is 2 into p by n, like that probability of ith element is p by n. Okay, the meaning here is the searching key will be available in anywhere in between here. The searching key, the probability of searching key will be somewhere here. If the key does not exist, then the probability is n into 1 minus p. When you put this p by n outside the bracket, we found p by n, and this is the formula 1 plus 2 plus like that one up to n, and the n into 1 minus p is outside only here. Okay, when you solve this formula 1 plus 2 plus, it's a series, it's a simple form is nothing but n into n plus 1 divided by 2. The simplest form of this one is n into n plus 1 divided by 2, and we have a formula like this way. Okay, here n and n goes, you found p divided by 2, here n plus 1 into n plus 1, this is the formula you found. Now if the p value is if the p value is 1, that means search is successful. If the p value is 1, that means here search is successful. Then what happens? 1 minus 1 becomes here 0. This entire expression becomes 0. Here p becomes 1, that is nothing but here it's nothing but n plus 1 divided by 2. It is nothing but n plus 1 divided by 2. Whenever the successful search is there, the probability of finding value is here n plus 1 divided by 2. If the p value is 0, that means search is unsuccessful. That here this entire expression becomes 0 here, and here it becomes n. So the probability of unsuccessful search is n. Our expression is correct. Our assumption is correct.